Man, you can't leave this guy alone in my shop. Joe, come here. Alright. So my guess is that maybe just one of the bearings of the shaft is broken, so let's open it up and have a look. What the hell is this? Warranty warning, do not open, do not use as a hammer. Of course not. As you can see, I did not open it. It did all on its own. It's quite amazing when you look at how tiny all this stuff is and in comparison what power it can deliver. Well, but now let's figure out where the issue is. So I guess I take all of that out first. Okay. I guess I should have removed the chuck at first. Oh, that's the motor. And that's the metal planetary gear reduction in here. Cool. Well, I really should have removed the chuck first. But that's the planetary gear system in here. Sometimes the threads on chuck screws are left threaded. Okay, so now we're back here and now I can take off this ring here. So there's, and open and close the chuck easily. So I put this one just back together and remove the feature. So now I can turn the motor. And of course, it also works. And all I did for it is leaving out these little pins. It's not that simple to explain, but I try my best. So in the front there are these pieces here. And these pins go in here. And this then gets closed with this cap. This cap is then fixed in the housing and the shaft joins here. When you take a closer look, you can see that this piece has two flat spots. And when you move the chuck, this flat spot slightly pushes the pins to the outside, and that's enough so that they jam up with this cap here, and when it's then jammed up, it's locked. And as it's symmetrical, this works in both directions. Now when the motor is on, these four pieces here, which are attached to the backplate, they move this piece and the pins simultaneously. So let's say when it rotates in this direction, you can see that it pushes against here, and at the same time the pins move also to this location. So it always pushes here, here, here and here when it's turning in this direction. And then you can see that the pins are at the center of the flat spot, which means they are closest to the center, and so they can't jam up with this piece here, with the cap, and then the mechanism is free to move. Pretty cool actually. Moving on to the clutch, so therefore you have this ring here and some steel bolts, and they just slip over these ridges of the ring. And that's where this noise is coming from. And with another steel ring and a spring and a plastic screw, and there you have your indicator. So the higher the number on the indicator is, the harder the spring gets tensioned, and so this mechanism can transfer more torque before the bolts slip over the ridges of the ring. Next interesting part is the gearbox. This is a 2-speed drill and it has two planetary gears. Now this is how it looks without the motor, and this here is the ring you can move to change the gears. So this here would be first gear. I'm turning on the end where the chuck is. This here would be the motor end, and as you can see, the motor would spin very fast and the chuck spins slow, but that means more torque. And this would be second gear. As you can see, motor spins slower, chuck spins faster, but less torque. The way this works is, this one is the ring that moves, and as you can see, it can interlock with this one. And when they are locked together, this is first gear. And in first gear, when they are locked together, you can see that both planetary gears work and reduce the speed. And in second gear, these inner teeth interlock with these teeth. And when these are locked together, you can see that the second planetary gear is not active, but just the first one. So that means higher speed and less torque. And the gear coming out from the gearbox connects to the last planetary gear, which is attached to the shaft connection with the outer ring. And as you can see, the shaft is not driven by the middle gear or the ring, but by the planet gears. When it's assembled, it looks like this. So now we are in second gear. If I switch to first gear, and you can see the end spins much faster. And second gear. And here you can see it again in action. So this would be first gear, second gear. First gear, second gear. That's all there's to it. Now, one problem there could be is that you can't switch the gear at every position because sometimes the teeth of the movable ring just don't mesh up with the other one. And so the mechanism just refuses to switch. But as you know from experience, you can always switch the gear, no matter where the drill stops. So how did they solve that? So this tab of the movable ring fits into the switch handle and it is spring loaded. And it also has its own springs, so it makes the clicking noise in the housing. And with this being spring loaded, you can always switch the gear. And if the teeth don't match up, the spring still continues to apply pressure, and once you start the drill, it will then automatically click into place and the gear is then finally switched. And these were pretty much all the mechanical parts of a small drill like this. Of course, there's still the motor and the electronics, but I'm not too familiar with that, so all I can tell you is it works like this. And this is as far as my knowledge goes there. So yeah, let's put it back together.